Hello, welcome back to my YouTube channel. So now I'm going to tell you about median test. So it is one of the method in non-parametric test for two independent samples. In order to test the non-parametric test, two independent samples, this is one of the method, median test. And the other method is Mann-Whitney U-test and Wolf-Wolfers run test. So these are the three methods in order to test two independent samples in non-parametric test. So now we are going to learn about median test. Okay, shall we? Okay, so median test is a statistical procedure. We all know that this is a method in statistics, so that's why it is called as a statistical procedure. Okay, so statistical procedure for testing. So for testing what? Two independent samples. Okay, for testing if two independent samples, two independent samples differ in their central tendency. So central tendency in the sense what? Nothing but median. So median is one of the method in central tendency. So this median test is used to test whether the two different samples are having same median or else different median we are going to test. Okay na? So in other words, we can say that it gives information if two independent samples are likely to have been drawn from the population with the same median. So we can say in this way, or else we can say like this, the same will be the same meaning. See here, in other words, it gives information if two independent samples are likely to have been drawn from the population. That means in one population we are going to draw different samples. So the two samples are having what? Same median. Okay na? So the two samples which we are drawn from the same population will be having what? Same median. So you can write this one or else this one you can write, but the same are, the meaning is same. The two sentences will be the same meaning. Okay, so now, so we all know that as in run test. So we all know what is run test. Run test, let x1, x2 and so on xn and y1, y2 and so on yn2. Here you keep n1. Okay, yn2 be two independent samples. Two independent order samples are you can call, or else simply you can call samples. Order samples from the population with probability density functions, f of x and f of y. That means here we should have definitely two samples. Why? Because this is a method comes under independent samples, two independent samples. So that's why we have taken here two samples. Its name is x1, x2 and so on, y1, y2 and so on. And these samples are having what? Same probability density functions. Okay, now these samples will have what? Same probability density functions. Okay, na? So we all know that density functions are denoted with f of x and f of y. Okay, so respectively. Next, so first they are having same probability density functions. Okay, and next is the measurements must be at least ordinal. What do you mean by ordinal? What do you mean by ordinal? Ordinal in the sense it's a ordinal scale. Measurements of scale will have ordinal, no? So that ordinal. Okay, na? So at least ordinal. Ordinal in the sense what? Numbers. Okay. So let m1 be the number of x and m2 be the number of y's existing the median value m. Existing the median value m. Okay, of the combined sample, So that means here ordinal in the sense order. Okay, now it should be order and it should be numbered. Okay, so here see, for example, some samples are there. Okay, first two samples are there. No, first we have to write the two samples combinedly. We have to write in a order. Either it may be ascending order or else descending order. We have to write. After that, we have to find out the median. So median, for example, if median is 20, so the samples, the numbers in the samples which are greater than median will be treated as m1, which are less than this 20 will be treated as m2. Those names are x, y. Okay. So the second point is that one. And next, and the next is, now what we have to do is we have to set up null hypothesis. So in null hypothesis, what we have to do? Null hypothesis. So in null hypothesis, we have to think that the two samples, okay, the samples come from the same population with the same median. That means the two samples should have the same median. Okay, so let it be h0 such that f of x equals to f of y. And what is alternative hypothesis? Alternative hypothesis is the samples come from the same population but they won't have same median. That is the alternative hypothesis. Okay, so alternative hypothesis. The samples come from the same population, or else you can take the samples from different populations also you can take. Okay, same population will not have same median. Okay, will not have what? Same median. So that is nothing but h1 such that f of x not equals to f of y. Okay, so this is about null hypothesis and alternative hypothesis. Next is, so test statistic here. The next is test statistic. So that is nothing but the joint distribution. So we all know that when we are using x and y variables together, it comes under joint distribution. Okay? If you are using only one x or y, it comes under marginal. Okay, but here we are using x and y, f of x and f of y. Two we are using. That's why the joint distribution of m1 and m2 is the hypergeometric distribution. Here the formula follows, the test statistics follows what? Hypergeometric distribution is the hypergeometric distribution. Okay, so that is P of m1 m2 equals to n1c m1 into n2c m2 by n1 plus n2 c m1 plus m2. See, in any formula, two functions are not included except geometric distributions. So that's why here the median test follows geometric distribution. Okay, and if P of m1 comma m2 greater than alpha by 2, alpha by 2 in the sense you all know that it is level of significance, then accept H naught. H naught in the sense what? Null hypothesis. What is null hypothesis? The samples come from the same population with the same median. We have to consider it is true. If this condition is false, then we have to say that reject H naught and accept H1. Okay, na? So now this is about small sample test. If it is in large sample, what is the formula? Nothing but large sample always follows normal distribution. So how the formula will be? In order to test the median test, we will see. Okay, if it is large sample, okay, for large sample, Z equals to m minus expectation of m by variance of root of variance of m. Okay, so where expectation of m equals to n by 2 comma if n is even, okay, expectation of m equals to n by 2 into capital N minus n by capital N if n is odd. Okay, next, variance of m equals to n1 n2 by 4 into n minus 1 if n is even. Okay, next, V of m equals to n1 n2 into n plus 1 by 4n square if n is odd. Okay, let me say what happens to m1 and m2 here. Here we have to think that if it is large sample, m1 is here it is inconvenient to use this median test for large sample. Okay, now so at that time we have to consider only m1. We should not bother about the m2. Okay, why? Because here m1 and m2 are same, we are going to consider. So that's why here we have to consider only m1 in the formula. Okay, na? So hope you all understand. Okay, and next, what about this conclusion then? So nothing but we all know that for large sample, calculated value is less than tabulated value. What we have to do is we have to accept null hypothesis. Okay, otherwise we have to reject null hypothesis. Okay, so this is very easy procedure. Hope you all understand this procedure. Okay, so once again you see this video so that you can able to understand clearly. Okay, so hope you all understand this one. So if you are newly watching this channel, please subscribe to my channel for latest videos, and don't forget to like. If you give like, so the video will reach to many people, so please like the video if it is useful for you, and don't forget to subscribe. Okay, thank you, have a nice day.